Well, looking at the structure of malpighian tubules, the excretion of nitrogenous waste in insects as a product of digestion. So we've got to consider the head, the thorax, the abdomen, and mainly the midgut, hindgut and rectum, where you'll find the malpighian tubules infiltrating into the hemolymph. Let's zoom in on the hindgut, rectum and malpighian tubule area and see how does an insect get rid of that nitrogenous waste. So it's got to create a flow, and the flow is the water that's containing the solutes of digestion, which contain sodium, chloride, glucose, which are useful, and then the waste in the form of uric acid, and it's all dissolved in the water. So that gets absorbed in the hindgut into the hemolymph. Sodium is actively pumped out of the hindgut. Chlorine follows and water will follow with those things dissolved in it. Sodium is then actively pumped into the malpighian tubule. Chlorine follows, creating a hypertonic solution inside the tubule, and therefore water will flow. So water starts to flow through the tubule down back into the hindgut and creates a bit of a circulation of that solute. In order to reabsorb water, to prevent water flowing out through the rectum, sodium is pumped out again in the rectum and uric acid is left. So let's look at it with some arrows. So sodium pumped out, chlorine follows. Sodium pumped into the malpighian tubule, chlorine follows. Water flows in, containing the solutes of water plus uric acid. Let's get that written down so that's really clear. And this forms a circulation with the uric acid back into the hindgut. And sodium being pumped out right near the rectum allows for that uric acid to crystallise because water is removed there, crystallising the uric acid, and therefore the insect doesn't dry out. It can preserve its water, it osmoregulates, and uric acid is excreted